is Grade 12 University Physics, Unit 2, Energy and Momentum, Lesson 4, Elastic Potential Energy. In this question, we have an apple of mass 0.1 kilograms attached to a vertical spring with a force constant of 9.6 newtons per meter. The apple is held so that the spring is at its unstretched equilibrium position, then it's allowed to fall. Neglecting the mass of the spring and its kinetic energy, what is the speed of the apple when it has fallen 11 centimeters? So in this question, we're going to look at conservation of energy. In order to do that, it's good to choose 2 points in time and then compare the energy before and after. So at our first point, we simply have the apple being held at the spring's unstretched equilibrium position. So if it's unstretched, where x equals 0 at its equilibrium position, then we have no elastic potential energy. It's also being held there, so it's not moving either, so it has no kinetic energy. It only has gravitational energy. Now once we let it fall 11 centimeters, the string is now stretched, so we have elastic energy. It's still moving because nowhere in the question has it said it's reached some maximum extension, so it's still moving. So we have kinetic energy, but we can choose this height to be a level of 0, because for gravitational potential energy, we can choose h to be 0 where we would like to. And so if we choose this point to be 0, we have no gravitational potential energy. So here we can set up our equation for energy conservation, where the total energy before equals the total energy after. Before, we only have gravitational. After, we have elastic and kinetic. Then we substitute the equation for each type of energy. And in this case, it just so happens the way we've chosen h is so that the value of h after is equal to the value of x. Both h and x are 11 centimeters. And so we can replace h with x, but only in this special case. Then when we rearrange and solve for our velocity, we get for the velocity after to be 1.0 meters per second.